Hello everyone. Today we're going to look at another sampling distribution which will be for the sample variance, and it's a little bit disguised in this problem in the form of sample standard deviation. But similar to the previous video here, we've got the same normal population with mean 50, variance 25. We take a random sample of 20, and now the question is asking, well, what's the probability the sample standard deviation will be over 7? So if I write that out, I notice random variable of interest is sample standard deviation. So I want the probability that sample standard deviation S is over 7. Now, we don't have the convenient property of the sample mean like we did, but we do have another standardization, and that is for a chi-square distribution. So if we recall, let me change here, that the chi-square distribution, which has this fancy X symbol on n-1 degrees of freedom, is equal to this equation. Now, a chi-square distribution is just another distribution. It looks like your standard normal distribution, except scrunched to the left a little bit. But how we standardize it in order to use the chi-square table to find probabilities is by this equation. So what I want to do is I want to make my simple S over here look like this equation so that I can convert it to chi-squared. So this is what I will do. First, I need to square the S. And then I need to make some modifications. The modifications will be multiplying by n-1 and dividing by sigma squared. Now, recall from algebra that whatever I do to the left, I must do to the right. So my first step is I have to square both sides from s squared to 7 squared. And then now I'm going to multiply both sides by n-1. N is our sample size, so that's 20 minus 1. And then sigma squared is the population variance, which we have up here as given to us as 25. So all I'm doing here is just modifying my original probability statement from S to this guy right here in the red box. And the whole point is this is your chi-squared distribution. And if I do some arithmetic to the 20 minus 1 times 7 squared over 25, this will give me 37.24. So the original question is, well, what's the chance the sample standard deviation is over 7? After our standardization, we converted the sample standard deviation to a chi-squared. And so now that it's in this chi-squared form, we will hop over and look at the chi-squared table. So what we want is we want the probability that chi-squared is bigger than 37.24. All right, so here we are. This is our chi-square table, and again, I'll write out what we want. We want the probability that our chi-square distribution is greater than 37.24. And you'll notice we've been writing the degrees of freedom down here, n-1. That is this Greek letter nu, that looks like a V. This is degrees of freedom. So right above it, you see here, degrees of freedom. And this is a table. You can see at the top here, table 7a from your textbook. Now, how to read this table, we'll walk through that. So our degrees of freedom will be 19, right? Because our sample size was 20. So we want to look at 19 degrees of freedom, which is going to be this row here. And the critical value that we're looking for, right, this chi-squared on this graph for us is going to be 37.24. And the table will give me this area to the right. And these are these probabilities up here. So if you read the title of the table, right, it's a little small, but right here at the very row in the bubble, it says probability of exceeding the critical value. Now, what's going to happen is I'm going to look for this number, 37.24, but chances are I'm not going to find it. But what I'll notice is it's in between these two values here. So let me highlight a different color. So this value means that the probability that chi-squared is bigger than 36.19, well, that probability is 0.01, right? Because that's the column that it's in. And then this probability that chi-squared is bigger than 43.82, well, that is equal to 0.001. And ours is somewhere in between. So the conclusion using the table here is our best estimate for this probability is it's somewhere between 0.001. So that's going to be smaller than our probability, and I'll write it out. Chi-squared is greater than 37.24. And that, in turn, is also smaller than 0.001. And remember that this was the original question of, well, what's the chance our sample standard deviation exceeded 7? So that is how we walk through a chi-square table.